Hello everyone. Today I am going to discuss the topic that is the design model and the design model elements from the chapter number 5, that is design concepts. Let us start with the topic that is the design model. Software design is a process of defining software methods, functions, objects, and the overall structure and interaction of the code so that the resulting functionality will satisfy users' requirements. The design model can be viewed in two different dimensions, as you can see in the diagram or in the figure. The process dimension indicates the evolution of design model as design tasks are executed as a part of software process. The abstraction dimension represents the level of detail as each element of the analysis model is transformed into a design equivalent and then refined iteratively. Referring to this figure, the dashed line indicates the boundary between the analysis and design models. In some cases, a clear distinction between the analysis and design models is possible. In order, to some cases, the analysis model slowly bends into the design, and a clear distinction is less obvious. The elements of the design model use many of same UML diagrams that were used in the analysis model. The difference is that these diagrams are refined and elaborated as a part of design. More implementation specific detail is provided, and architectural structure and size of the components that reside within the architecture and the interfaces between the components and with the outside world are all emphasized. We should note, however, that the model elements indicated along the horizontal axis are not always developed in a sequential fashion. In number of cases, preliminary architecture design sets the stage and are followed by the interface design and the component level design, which often occur in parallel. The deployment model is usually deployed until the design has been fully developed. We can apply design patterns at any point during design. These patterns enables you to apply the design knowledge to domain specific problems that have been encountered and solved by others. So all these are the some points regarding the design model. So let us start with the first one, that is the data elements. So basically data design, or we can say the class design, it transforms analysis classes into design classes along with the data structures required to implement the software. Let's have a look at the data design elements. So the data design element produced a model of data that represent a high level of abstraction. Then this model is then more refined into more implementation specific representation, which is processed by the computer based system. The structure of data is the most important part of the software design. So all these are the different points regarding the data design elements. Let's have a look at the second element of the design model, that is the architectural elements. So the architectural design elements provide us overall view of the system. The architectural design element is generally represented as a set of interconnected subsystems that are derived from analysis packages in the requirement model. Basically, we can say the architectural design defines the relationship between major structural elements of the software. Architectural styles and design patterns help to achieve the requirements defined for the systems. The architectural model is derived from the following sources, maybe from the application domain, analysis classes, their relationships, collaborations, and behaviors are the sources of the architectural model that is derived from these sources. Then it may be transformed into the design realizations. Then patterns and styles, both these are the things, that's why these architectural elements we are going to prefer. If we are using better pattern and styles, then obviously our project will be provide the quality to the customer, so the customer satisfaction may be achieved. Now let's have a look at the interface elements. So that is the second element of design model. Basically, interface design describes how the software communicate with the systems that operate with it and with humans that use it. So the interface design elements for the software represents the information flow within it and out of the system. They communicate between the components defined as a part of architecture. Then the following are the important elements of the interface design. The first component, that is the user interface. Second one is the external interface to other systems, networks, etc. The internal interface between various components, that is the we can say important elements of a interface design. Look at in this diagram, we have one interface that is very important. It's a keypad which contains two operations like read keystroke and decode key that should be implemented by its derived class. So the basically that keypad, so that is the interface for the wireless PDA or for the mobile phones. And again, one more thing that is very important, that interface keypad, which actually gives you one kind of contract. With the help of that contract you can access the things. So for that purpose you have to follow some rules and the regulations of that interface. So here one more class, that is the control panel, which contains the LCD display, then speaker, So all these are the attributes of the control panel class, and the operation performed by this control panel are like decode key, then display status, etc. So basically we can say the interface design describes how the software communicate with the systems that incorporate with it and with humans that use it. Then let us move to the component level design. So basically it transforms structural element of a software architecture into a procedural description of a software components. So the component level design for the software is similar to the set of detailed specification of each room in a house. The component level design for the software completely describes the internal details of each software component. Also, the processing of data structure occurs in a component and an interface which allows all the component operations. In a context of object-oriented software engineering, a component shown in a UML diagram. The UML diagram basically is used to represent the processing logic. So it's a very simple example of component elements. Like here we have two elements. First one that is the sensor management, and the next one that is the sensor. So sensor management manages the sensor. So this is about the component diagram. Then the last element, that is deployment level design elements. So the deployment level design element shows the software functionality and subsystem that allocated in the physical computing environment which supports the software. Following figure shows the three computing environments as shown. These are the personal computer, the CPU server, and the control panel. Look at here, this is the deployment elements. As I have already discussed that this deployment elements, it shows the actual nodes present in our system whenever we are going to deploy our system. So here one control panel, then CPI server, then one process computer. So all this about the deployment elements. Thank you.